And we are live. So, welcome to Climate Chat. I am your host, Dan Miller. And today, instead of talking about climate denial with Tad Delay, Tad, oh, I got to turn off a second instance just popped up there. Sorry. Um, Instead of talking about climate denial with Tad Delay, Tad's not feeling well today, so we're going to reschedule Tad. And today, instead, we're going to be talking about a brand new report that just came out this week from the University of Exeter in the UK. And it's not just the general climate science group, it's from the Institute and Faculty of Actuaries. Actuaries are the folks who figure out the statistics to help set insurance premiums, for example. They take a look at the risk of your house burning down or you being in a car accident or whatever the case, you slipping and falling on a banana peel. Uh, but they're also the right kinds of folks to take a look at the risks of climate change. And it turns out that, as you might expect, we haven't really been looking at the risks properly. So first of all, let me just pop up, let's see. I got to get over to this other one, get over to that, close that out and share my screen here. Okay. So, and Stacy, tell me if there's anything like wrong with what we're seeing. You should be seeing a little bit of me and mostly the report
Yeah,
heading.
I mean, I might make it full screen, but other than that, it's good.
Yeah, let's try that. Safari. Um,
View.
oh, well, when it's in full screen, I think I have to stop it first before I do that. I don't see how to make it full screen while I'm within it. It kind of takes away.
Hmm,
Oh, I have view up there. Let's try it. View, enter full screen. Did that help?
that surprisingly made it zoom
Work?
back further, which is odd, but it's fine either way. It looks totally fine.
Okay. All right.
You
Anyway,
can
so
probably go back to the view that you had before, and you can probably zoom in so that it yeah.
okay, I will zoom in. That made it smaller from my side. How's it look to
No, that
you?
did make it smaller.
It did the same thing
Oh,
as
wait.
full screen.
Zoom in again. Try. There we go. And I'll go one more time. Let's see. Zoom in. How about that?
Sure. Yeah, it'd just be nice to not see the menu bar, but it's not worth
Eh,
it. Hmm.
okay. All right. Anyway, so that's the title of the report, Planetary Solvency, Finding Our Balance with Nature, Global Risk Management for Human Prosperity. So again, this is the University of Exeter, the Institute of and Faculty of Actuaries. So this is not like a radical hothead group of people trying to push a climate agenda, a Green New Deal. These are very conservative folks who look at risk. And a quote I like to say is that climate scientists are conservative in the opposite way that a risk manager, such as an actuary, is conservative. And that's what we're going to find today. And this actually is appropriate given our discussion last week with David Keith, who brought up the fact that studies have shown that even with climate change of 2.5 degrees warming by the end of the century, that GDP would only drop about 2%. And they directly address that issue here in this report, and we'll take a look at that. So, this is trying to give a balanced view. They're speaking of balanced view, balancing. Right now, nature is has the upper hand here, and I'm sorry, industry has the upper hand, and we need to address it. So let's go into the report, it really is interesting to see the key findings. So I'm just going to kind of go through those. And again, if you have, this is an open discussion today. We don't have an interview guest, so you can raise your hand. Okay, let's see. If you're on YouTube watching, then put question colon at the front of your uh, comment in the live stream so that Stacy and Eli can find those and bring them up. And if you're on Clubhouse, um, you could put a comment or question in the comment section. And if you're on Zoom, you can put your question in the comments, and also you can. Oh, don't raise your hand though. Raising your hand kind of messes up the video stream. So, but if you do have a question there and I'll see it, I can call on you there. All right. So here we go. So this is the executive summary. The executive summary of what this report. It's a pretty long report, and it's a very interesting report, and it really backs up what it says. But these are the highlights. So the critical observations. We are part of the Earth system, which we depend on. Well, that seems like a pretty obvious statement, but actually, the way we treat the economy is as if the nature and things are an externality. But in fact, the economy is a wholly owned subsidiary of nature. Anyway, it says our society and economy fundamentally depend on the Earth system, which provides essentials such as food, water, energy, and raw materials. These ecosystem services, including climate regulation, are not substitutable, meaning they must be protected as they cannot be replaced by technology when they are gone. This means societal development, well-being, prosperity, and economic health are intertwined with and dependent on the Earth system. We need to recognize this dependence and manage our activity to be within planetary boundaries. An urgent policy response is required to achieve this, as our current market-led approach to mitigating climate and nature risks is not delivering. So all of that actually should be pretty obvious that we depend on the Earth for our survival, our flourishing. And yet it is also true that we don't treat it that way. So that's number one of the critical observations. Number two, the stability of the Earth system is threatened. I'm going to bring this down here 1 second. I don't look like I'm looking up all the time. If I can. That didn't really work, did it? Oh, because I'm screen sharing. Uh-huh. There we go. I can't. It's gone. 1 second. Let me find it again. Wow. Gonna have to move all this away. I'm sorry about this. Wow. It just disappeared. Wow. But you're still seeing it, right, Stacy? That's a weird thing. Stacy, are you there?
Yeah, I'm there. Sorry. I was trying to find my version of it to see if I could back you up. Um,
This is very strange, but I know it has
no,
to be
it's
here.
just it's like a black browser weird, and it's the YouTube window rather
So I'm
than
going to stop sharing for I'm going to stop
yeah.
sharing. I'm sure it'll pop back when I do that.
Yep.
Um, and I'm going to make a new tab to bring it. I can't even do that. Oh, sorry. Did I do something? I did something funny there. And wow, that was a very strange thing. Okay. So I'm loading it on a different tab. And I'm not going to move it this time. I don't know what happened there. Um, let's see, go to share. Um, okay. You should see it again.
Yep,
It's
you're
probably a
good.
little farther away this time, but
That's fine. You're good.
do do it one more time here. Okay, sorry about that. A little interruption. The stability Earth system is threatened. Climate change and nature loss driven by human activity threaten the stability of the Earth system. Impacts are already severe with unprecedented fires, floods, heat waves, storms, and droughts. If unchecked, they could become catastrophic, including the loss of capacity to grow major staple crops, multi-meter sea level rise, altered climate patterns, and a further acceleration of global warming. We risk triggering tipping points such as Greenland ice sheet melt, coral reef loss, Amazon forest dieback, and major ocean current disruption. Tipping points can trigger each other, causing a domino effect or a cascade of accelerating and unmanageable damage. If multiple tipping points are triggered, there may be a point of no return, after which it may be impossible to stabilize the climate. So that's pretty serious stuff. And yeah, if you're listening to Climate Chat, you know this, but this is not the way the world is responding to what's going on. It's not the way this is not the information policymakers have. They heard about the 2% drop in GDP. So they said, well, if it's a 2% drop in GDP, we shouldn't take action to cut back on fossil fuels too quickly because that would lower GDP even more.
We're
So
not we're not looking up.
we're not looking up. Okay. And here, now let's get into, so the last two things, if you follow Climate Chat, you know those things. You know that we live on Earth and Earth supply is important things to us, and you know that there's a danger of climate change. And now let's get into uh, the risks and what we've done so far in taking a look at the risk, or how policymakers have looked at risk. Three, unmitigated climate change and nature-driven risks have been hugely underestimated. Climate change impacts are materializing at lower temperatures than estimated. The severity and frequency of extreme events are unprecedented and beyond model projections. This is now a matter for human security, with human populations impacted by fires, floods, food system shocks, water insecurity, heat stress, and infectious diseases. If unchecked, then mass mortality, mass death, involuntary mass migration, severe economic contraction, and conflict become more likely. Severe societal upheaval could spread from vulnerable regions through our globalized socioeconomic systems, driving responses such as food and water hoarding, acting on feedback loops to worsen social, economic, and political challenges. Our agency to mitigate climate may be progressively eroded or derailed as resources become constrained by the need to respond to increasingly chaotic physical and socio-political events. So now we're getting in the meat of it here. And this is 4. Paris Agreement goals were not informed by realistic risk assessment. They implicitly accept high risk of crossing tipping points. The average temperature for the last 12 months was 1.5 C above pre-industrial temperature, and the rate of warming has accelerated. Breaching 1.5 C risks triggering multiple climate change tipping points, and every fraction of a degree increases the risk. There is a time lag between emissions and the warming that is experienced, meaning that unless emissions are reduced, more warming is in the pipeline. The Earth may be more sensitive to greenhouse gases than we thought, which means net zero carbon budgets may now be negative for the 1.5 C goal. That certainly is true. Ongoing emissions and the loss of natural carbon sinks will drive further warming and more severe disruptive events globally. Research is required to inform actions to limit these impacts. Okay, so that's about Paris. The next one, 5. This is just the executive summary, and the report itself provides detail on all of these things in detail below. 5, global risk management practices for policymakers are inadequate. We have accepted much higher levels of risk than is broadly understood. Policymakers often prioritize the economy with their information flows focused on this. But our dominant economic model doesn't recognize a dependent on the Earth system, viewing climate and nature risks as externalities. Climate change risk assessment methodologies understate economic impact, as they often exclude many of the most severe risks that are expected and do not recognize there is a risk of ruin. They are precisely wrong rather than being roughly right. Love that line. They are precisely wrong rather than being roughly right. This, by the way, directly is on topic to what we talked about David Keith last week. So we'll get into that part in more detail. The degradation of natural assets such as forests and soils, or the acidification and pollution of the ocean, act as a risk multiplier on the impacts of climate change and vice versa. Traditional risk management techniques typically focus on single risks in isolation, missing network effects and interconnections, underestimating cascading, compounding risks. Current risk management approaches fall short of the resilience principles detailed in this report for realistic and effective risk management. Consequently, policymaker risk information is likely to significantly understate the potential impact of climate and nature risks, weakening the argument for urgent action. These limitations mean that policymakers are likely to have accepted much higher levels of risk than is commonly realized. So here we go. So that's the executive summary of the observations. They also have a summary of recommendations on what to do. So this is recommendations to mitigate risk. And so we'll just read through those two, and then we're going to dig into not the whole report, but into key parts of the report. Recommendations to mitigate risk. To mitigate the risk of planetary insolvency, just think about that phrase, planetary insolvency, and prepare society to be resilient to those impacts, which are unavoidable, policymakers must implement realistic and effective approaches to global risk management. Our recommendations are to: 1. Implement planetary solvency assessments. Establish independent annual risk assessments to provide clear global systemic risk information to national and supranational governance institutions. Given the level of risks to peace and security, an independent body could be commissioned to provide planetary solvency assessments to the UN Security Council. These risk assessments should leverage the resilience principles detailed in this report for realistic and effective global risk management. The Security Council could then cascade these risk assessments, integrating them into global initiatives such as the Pact for the Future, ensuring a structured risk-led approach. 2, set planetary solvency limits that respect planetary boundaries. Develop risk limits and thresholds to manage our activities within these. Develop a range of metrics that monitor planetary health, as well as human societal indicators, such as the economy, health, equity, food, and water security. Use the precautionary principle when faced with uncertainty, for example, to minimize likelihood of breaching tipping points. Excluding risks due to uncertainty breaches the precautionary principle. A best estimate is better than no estimate at all. People don't realize that a lot of things in climate models are left out because they don't know what they are, even though they're very, very important factors. Revisit climate goals from a risk perspective and implement a process to update carbon budgets annually, which accounts for warming experience and emissions. 3, enhance governance structures to support planetary solvency. Formalize planetary solvency to provide relevant bodies and the public with concise, risk-led information on risk implications of failing to meet global goals. Initially, this could be the UN Security Council or a member nation of the UN Security Council, before cascading to other relevant parties such as international financial institutions and relevant international regional forums. Provide information in an easy-to-digest form built off realistic systemic risk assessments that recognize tipping points and other nonlinear risk drivers. This may help to support the achievement of other goals. For example, Article 12 of the Paris Agreement around climate change education and awareness. Improve transparency by reporting risk assessments publicly. Okay. 4, build policymaker capacity on systemic risk management. Enhance policymaker understanding of ecological interdependencies, tipping points, and systemic risks so they understand why these changes are needed. Assess how to embed systemic climate and nature risks into the risk management process of nation states, in line with work from the IPPR, which states climate change should be a core part of national security planning. Produce a planetary solvency risk overlay to complement key global scientific outputs to sit alongside the IPBES and IPCC summaries for policymakers. Risk outputs should be independently produced in line with the resilience principle without allowing signatories to veto content. Risk outputs should always identify areas for further research and commission where more information is needed. And then 5, take action to mitigate risk. Create incentives and design policies that enable societies to collaborate towards just and sustainable futures within planetary boundaries. Explore options to limit global warming and avoid triggering tipping points. Given the risks, uncertainties, and economies, policies should be explored to 1, accelerate decarbonization by reducing emissions to zero as quickly as possible by identifying and leveraging positive socioeconomic tipping cascades. Remove greenhouse gases from the atmosphere. Repair and restore damaged parts of our natural ecosystems. Explore further emergency action which may be required to slow global warming. I assume they mean SRM there, solar geoengineering. Build resilience to worsening and inevitable climate impacts. So there you go. And then in the, by the way, I don't know if there's comments or questions on that. We could stop, and do that anytime. But so if someone, let me turn on.
Yeah. The only one I saw, oh, wait a minute. There's another one. Sorry. The one I saw, I answered, which was about water hoarding. And what is that? And I said it would be like Colorado versus California, Arizona, New Mexico, Nevada.
Or more importantly, internationally, where
Right.
one country is building a dam to hold in water for their farmers, and then it blocks the water from reaching another. Like imagine that happening between Pakistan and India, both nuclear powers. It's not the kind of thing. I'm going to get off of there for a second so I can pull up. So there's nothing in the chat. Okay.
And then
yeah.
another question is, let's see, Reese says, interesting that they bring up the lag between emissions and heating. Climate scientists keep going on about the report that heating stops as soon as humans stop emitting, which, yeah. What are they thinking?
Well,
yes, I know the oceans will take up more once we relieve that pressure, but it's in the pipeline, people.
Well, yes. So just very quickly on that. But both are true, by the way. When you continue emitting, the impact from the stuff you emit today, actually, you start to see them a few decades later, very often, not just immediately. But it's also true, and this is how it goes. If we cut our emissions to zero, and by the way, that's a scenario. It's like we're not cutting our emissions to zero. We should be clear about that. We're not doing it. We're saying we want to do that in 2050. We're not on track to do that in 2050, but things can happen. Maybe we can change our mind and get to there. When you get to zero emissions, true net zero emissions of human activity, and we're lucky that perhaps tipping points like permafrost feedbacks and methane releases from the Arctic Sea and things like that don't happen to keep adding greenhouse gases to the atmosphere, even though we've stopped doing it. In other words, the Earth keeps putting more up there and we triggered that. But so assuming that's not true.
The sea ice extent at both is at record lows.
Yeah, but the theory of temperature, not that it drops, but it stops going up if we stop our emissions, is because there is an Earth energy imbalance, and that means the Earth will keep warming until it reaches until that Earth energy imbalance is zero. And the way it gets to zero is the Earth gets hotter and hotter, and as it gets hotter, it radiates more energy into space. So it's getting rid of more and more energy until finally it's balanced. But that's one thing that happens. So that would just keep the Earth warming for quite a while. The other thing that happens is when you stop emitting CO2, when we emit a ton of CO2, a large 55% of it gets absorbed by the ocean, soils, and plants on Earth. And those processes will keep going because there's too much CO2 in the atmosphere. It's out of balance. And so it's going to keep absorbing it. It won't know that we shut off emissions. It doesn't know because it only cares about the total in the atmosphere. It doesn't care about the annual amount. And since
Right.
the total is so overburdened, we have 50% more CO2 in the atmosphere than we had before the Industrial Revolution. That absorption by the ocean, plants, and soils will continue, and that will actually draw down CO2 levels um, over time, and that will be a cooling factor. Now, um, now, of course, if we keep emitting like we are, then that doesn't work. But if we did shut off all our emissions, those two things should cancel each other out theoretically. Now, Jim Hansen says that the Earth climate sensitivity is 4.8 C instead of 3 C, which means there's sort of more warming from greenhouse gases than we expect. So that may not be true, but still it should stabilize maybe with 1 degree more, which is still a huge amount. But
And remember, we had that recent geological record paper that showed that it was actually much higher over long terms than the geological record, the equilibrium sensitivity.
although there's been other papers that said it was less, too. I mean, to be fair, right? Over the last year, there's been a bunch of papers on this subject. But I'll go with Jim Hansen. And by the way, update on Jim. He did write to me and said his new paper's almost ready. So keep an eye out for that. And we're going to have an interview a week or so after it comes out. So not sure exact timing, but sounds like it's going to be released, I would say, in January. And so we should have an interview with him end of January, early February. Okay, but two more things on the Earth balance, Earth temperature stabilizing when we stop emissions. Then there's two more things that happen. One is that if we're not emitting fossil fuel emissions, then we're not emitting all that sulfur, like from ships and coal plants and cement plants, all that kind of stuff. And that's cooling the Earth a lot. And that would go away and warm the Earth up, as we're seeing when we cut back on ship emissions. We had a lot of shows on that. But on the other hand, methane, which is about 2/3 of the warming of CO2, um, that would go away because we're not emitting it anymore. And the good news about methane is even though it's a very powerful greenhouse
Sorry,
gas,
sorry, wait a minute. What is triggering the no methane?
we're stopping our emissions.
Oh, if we're going
If
for
we're going to
zero.
zero emissions, that means zero
Oh,
methane
okay.
emissions
Okay.
too. And zero methane emissions, that means plugging up the holes in all the leaky wells too.
Right.
But whatever. That's not that hard to do, actually. But so when we have zero methane emissions, it goes away over like 15 years. It breaks down in the atmosphere to CO2 actually, but it's 120 times as powerful as CO2 while it's in the atmosphere, and that's
Wait,
why when we measure CO2, the CO2 warming is due to an increase of 120 ppm. Right, it went from 140. It went from 280 to roughly 420.
wait,
And
wait,
so
wait,
that's
wait.
an increase of 140 parts per million. The methane, we've increased by 1 part per million. And yet, it's like 2/3 the warming of all that CO2. So 1 part per million, I'm rounding off a little bit on the methane. It's a tiny
Sorry,
bit more.
sorry. Today I learned when methane breaks, I knew it's like, oh, please say it one more time. Methane is how many times the warming of CO2?
While it's in the atmosphere.
While it's in the atmosphere, yeah.
It's about 120 times as powerful, but you never hear that number. The number you hear is that it's about 86 times or it's about 30 times. It's 30 times over 100 years because it's really powerful for the first 15 years, but I mean, it's like a half-life, so it doesn't like go 15 and boop, but and so it has, average life of about 15 years, 12, 15 years. And then for the rest of the time, it's instead of being 120, it's only one, or it might be two. I can't remember, depending where it comes from. But because it's just CO2 after that.
Right. But that's the thing I learned.
And that average might be 30 over 100 years. And if you look at it over 20 years, it's 86 because you got most of the warming for most of the time, and it's just starting to fade away after 20 years.
Methane breaks down into CO2.
CO2. But again,
I thought methane was CH4.
it is.
So it breaks. Okay, I have to go.
Okay, well, what happens is there's sunlight, ultraviolet light,
yeah,
and there's hydroxyl radicals, OH minus there, and the OH hits the CH4 and breaks it apart, and you get water. I guess you get water and you get CO2 because you got H's, right?
Okay.
H's, and you get CO2. So I mean, that's
the
simplified there a little bit, but
the production of hydroxyl radicals, there's a feedback loop with ozone in the stratosphere as well, and one of the complications of stratospheric sulfate aerosol injection, which hasn't really been talked about, is there is the issue that it may reduce ozone. Because ozone can react on the sulfate particles. But I don't think anybody's really looked into the feedback that would have on reducing hydroxyl production and hence slowing down methane degradation.
Well, that's it. Because David Keith, when we had him on last week, on his report that looked at the risk of doing SRM versus the risk of not doing SRM, they did take into account higher cancer risk due to SRM breaking down some ozone. It doesn't destroy the ozone. What I remember, it's like 1 or 2 years worth of repair of ozone is slowed down when you do SRM, something like that. But, and then what was the other reason? I forget what the pollution aspect of doing SRM. Of course, we're doing far more of it now than we would do in the future. But anyway, so one other interesting, while we're talking about it, we are jumping away from this paper, but the other thing is what we're talking about, how methane breaks down in the atmosphere. Well, the interesting thing about hydrogen, so let's say we do renewable hydrogen made from solar panels and wind farms, so not from methane the way it normally is. So it's green hydrogen. Well, of course, hydrogen is the smallest molecule, right? It wants to leak out of everything because it's the tiniest thing. So you have to be super careful. To the extent that it does leak out of your pipeline, out of your car, truck, whatever it is, it goes in the atmosphere. And one of the things it does is it joins with those OH radicals and turns into water. I forgot what it turns into, but yeah, H2O. So you get
it turns into water. Basically,
it turns into water and a little bit of oxygen. Oh, okay. Well, the water's not bad. Wait a second. You just got rid of my OH, which is destroying my methane. So it turns out that hydrogen, green hydrogen, is a very powerful indirect greenhouse gas. The hydrogen itself is not a greenhouse gas at all. It has just 2 atoms, and things with 2 atoms are not greenhouse gases because they don't flop around and catch infrared radiation. It's kind of the right way to think about it. You think of a CO2, it has the O2 is kind of flopping around, catching heat waves coming up from the ground. But H2 doesn't do that. It's very stable. And however, when it joins with OH, it gets rid of the OH, which destroys the CH4. So when you get rid of that, you have more warming from the CH4. And if I remember correctly, like hydrogen is just like methane is 86 times as powerful over 20 years. I think hydrogen is somewhere 13 to 30 times. I can't remember the number off the top of my head, but it's a very powerful indirect greenhouse gas. There you go. So now we had our little what happens when you cut emissions to zero deal, and that, by the way, if you're lucky, those okay. So let's summarize it: warming in the pipeline canceled by continued ocean uptake of CO2. Methane going away, that causes cooling, is offset by aerosols going away, that causes warming. And those two things cancel out, theoretically. and that assumes we don't hit a tipping point first. It also matters when you do it. Like, we could have done this 30 years ago, and it probably would have been true that temperature would stabilize right away. You do this in 2050, when other tipping points are kicking in, maybe, and then you get methane coming up from melting permafrost and other things happening. And by the way, none of this stops the oceans from rising, because 90% of global warming heat goes into the ocean. And remember, when this happens, if you're lucky, let's say you're lucky, temperatures stop going up, but they already are up, right? So you're at one point, let's say you obviously you wouldn't be able to stabilize below 2 degrees. So you're stuck at 2 degrees unless you do SRM and carbon dioxide removal.
When you're talking about going to zero, I think the thing I always have in my mind is, okay, no more fossil fuels, no more oil, no more natural gas, none of that, no more coal, of course, like
right.
All that goes away. But and I, we're not getting into a whole. How about the land use? How about the animal agriculture? All of that we
no. So
like getting
the
that to go to
IPCC
zero
addresses that, and what they say is that's why we need carbon capture, but why we only need a little bit of carbon capture. So, and roughly speaking, it's 25% of the emissions. So they're saying that we need about 10 gigatons of carbon capture every year, and let's say in the 2050 timeframe, to offset the gigatons, the 10-ish gigatons from agriculture and those things that we can't get rid of. Yeah.
Okay.
So,
and what is 10 gigatons in? How does that compare to what we're doing today?
So we're doing today, if I'm have it correct, there's about 42, 43 gigatons of emissions. I think the land use changes are sort of separate from that. I'm not sure if those are included, but it's about 42, 43 is about right. I think it's in here in the report too, probably somewhere. Okay, so maybe we get back to okay. Let's get back to the report. I'm going to share again because I want to cover something that we talked about last week. I'm going to just jump ahead here because they have a
we got a lot of comments about last week. So
yeah, we got a case study.
Back to that later.
Well, it was a very interesting discussion, and the bottom line of that discussion is that based on a fairly simple analysis, I would say, of the risk of deaths from doing SRM versus the deaths from not doing SRM, David Keith and his colleagues showed that the risk of doing SRM is significantly less, saving something like 400,000 lives a year. But I think they were actually being very conservative and leaving out lots of the risk, as this report is kind of talking about, by the way. The risk of not doing SRM is actually much higher than they were saying because they were doing a simplified model, just assuming certain risks, okay? Now, however, that's one thing. So that was about the paper. We also then spoke a little bit about this. There's a guy named Nordhaus who got a Nobel Prize in economics for doing climate risk assessment. And the bottom line is he said that GDP would only fall by 2%, I think under 2.5 degrees of warming by the end of the century. And therefore, if you balance the economy with the damage from climate change, you end up with an optimum warming of something like 3.5 to 3.7 degrees Celsius, which is insane. That's all I'll have to say. It's insane because that's, as Kevin Anderson said, 4 degrees of warming is not compatible with an organized global community. But it's not that his model was right if you assume his assumptions are correct. But he, for example, left out 87% of all industry because it was indoors, and he said therefore it won't be affected by climate change, which is, well, anyway, they're going to get into that here because it's kind of stupid. But just keep in mind that someone won a Nobel Prize for saying the optimum warming of the world should be 3.5, 3.7 degrees Celsius, which is absolutely utter catastrophe, and there's no way. But so David and I had a little back and forth last week where he said this, and I'm saying, well, that's not right. That's been debunked and everything. And he said, no, 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 it's he sticks by that. So he and I we were having an ongoing discussion after our conversation last week. But one thing that popped up during that week was this report, and it directly addresses that point. So let me read this part because this part relates directly to the concept that climate change will not impact GDP very much. As again, someone, I didn't hit share yet, did I? Here we go. Are you seeing case study climate risk assessments?
You're good.
All right, so this is directly on that. So I really like this part. For climate change, although it will have a range of societal impacts, significant focus is typically given to economic consequences, seeking to answer the question, what would the impact of climate change be on GDP? The answer to this helps to inform the question of prioritization. Unfortunately, many high-profile public climate change risk assessments are significantly underestimating risk because they exclude many of the real-world impacts of climate change, such as the impact of tipping points, extreme events, migration, sea level rise, human health impacts, or geopolitical risk. Furthermore, they calculate ongoing economic growth even in a hothouse world, as climate damages are lower than growth assumptions. These results conflict with scientific predictions of significantly reduced human habitability from climate change. These risk assessments are precisely wrong rather than being roughly right. The benign but flawed results may reinforce the narrative that these are slow-moving risks with limited impacts rather than severe risks requiring immediate action. That's a very important paragraph right there. Such an approach does not meet the requirement of the principles for risk management listed in Section 4, excluding uncertain, high-severity events from models, rather than making best estimates and adopting the precautionary principle. To address the potential global risk management failure and support the development of realistic planetary solvency risk assessments, we develop in this report a set of principles for realistic risk assessment, the resilience principles, characteristics that any global risk assessment methodology should meet. We then use these principles to develop illustrative planetary solvency outputs. By the way, where's the... Okay, we're going to keep going because this is all about the same subject here. The wide range of climate change economic impact estimates, and you'll see where David Keith got his numbers from. The Network for Greening the Financial System provides analysis of a range of estimates for the negative GDP impact of climate change under a current policy scenario of 3 degrees warming by 2100. These range from 2% GDP from Nordhaus and Boyer. Nordhaus, the one who got the Nobel Prize in economics. Impact to 44, okay, these range from 2% GDP impact to 44 GDP impact by 2100. Alternative methodologies provide wider range still, up to 63%. What is important to understand is that these results are the output of complex models, which are highly dependent on the methodologies used for calculation and assumptions. A prudent approach would be to take the highest estimate of economic loss and reduce it when evidence becomes available that is overstated, rather than the other way around. So rather than picking 2% and seeing if it's worse. In their latest update, the NGFS proposes using a GDP damage estimate based on the Kotz et al. Paper, The Economic Commitment of Climate Change, which estimates that physical risks from climate change in a current policy scenario might reduce GDP growth by roughly 1/3 by 2100, i.e. GDP is still forecast to grow in this scenario, but to grow less than it would if climate change didn't occur. And here's a picture of the what they're saying here. They're saying use this COTS thing instead of the old one. And as illustrated in figure 2 above, there is a large range of GDP loss estimates in the NGFS scenarios, with the gray shaded area of possible losses using this approach ranging from less than 5% GDP damage in 2050 to around 25% in 2050. This is a wide range, with the expected value, the blue line in figure 2. The blue line? What am I missing? I don't even see the blue line. Okay. The blue line in figure 2 showing a 15% reduction in global GDP by 2050. Okay. That's the red line, by the way. Okay. By 2050. The authors state these damages already outweigh the mitigation costs required to limit global warming to 2C. In other words, it will be overwhelmingly positive economically to limit global warming. In other words, it costs a lot less to stop global warming than it costs to accept it. However, the limitations of this assessment, based on the Kotz et al. Paper, show that it excludes many of the most severe risks that are now expected if we do not manage to limit global warming, as well as the assumption that an economic recession is impossible no matter how severe climate shocks become. Wow, that's a weird assumption. The approach does not consider the impacts of climate tipping points, climate-driven extreme events, human health impacts, resource or migration-driven conflict, geopolitical tension, nature-driven risks, or sea level rise. The authors themselves acknowledge that when these additional factors are considered, real economic impact will likely be greater than estimated in their study. And this I really like the next paragraph. This is analogous to carrying out a risk assessment of the impact of the Titanic hitting an iceberg, but excluding from our model the possibility that the ship could sink, the shortage of lifeboats, the death from drowning or hypothermia. The modeled results would be reassuring, but dangerous, as they would severely understate the level of risk. That is to say, even though the results show a very material reduction of GDP of 15% by 2050, it may be an underestimate as it does not capture all the risks we expect. So I think it's a nice way of putting it. Yeah, let's look at the risk of the Titanic hitting an iceberg. But let's not take into account the fact that the ship might sink, because that's a small probability, and
we don't
it's an
want to think
unsinkable
about
ship. That's, So, by the way, maybe we should pause if there are any further questions there. Well, we're almost done. This is almost done. 2 more paragraphs. However, some policymakers are still using the earlier Nordhaus damage estimate to justify an assertion that while climate change is of concern, it is not an immediate priority due to the negligible expected impact of 2% of GDP damage by 2100 at 3 degrees of warming. 3 degrees of warming. God. A deeper analysis of the assumption underpinning the estimate shows that as well as excluding, I'm sorry, I'm not getting it. A deeper analysis of the assumptions underpinning this estimate shows that as well as excluding from analysis many of the risks now expected to occur, It also excludes 87% of the economy from the analysis, assuming that a number of sectors will be negligibly affected by climate change. Basically, it says if you have an indoor business, you won't be affected by climate change, which is pretty, like insurance companies. They're indoors, so they don't get affected. Um, Although models typically provide thorough documentation and assumptions and limitations, few policymakers are likely to fully understand these. This increases the likelihood of policy decisions being based on model outputs that significantly understate risks and are inconsistent with climate science. Put another way, policymakers who use these model outputs may be accepting far higher levels of risks than they think. So I think that did a better job than I ever could in responding to what I was trying to do and responding to David's mention of the 2% reduction. He doesn't say it's going to be 2%, but I think he's saying it would be in that order of magnitude. But as they say in the modeling world, garbage in, garbage out. I mean, if you have a certain set of assumptions and you leave out the worst case ones. Stacy, I see a look on your face like you can't believe this.
Well, because
but
I went.
that is the correct face to show, by the
Yeah.
way. This is what, I mean, this is not a joke. This is what global climate policy is based on. If you're wondering, look, you might say, hey, I'm not a climate scientist. I'm not a policymaker. I assume that the climate scientists are telling the policymakers how bad it could get, and the policymakers are taking steps to protect us, protect ourselves and our children, protect our country, all that kind of stuff. And the answer to that would be no. The climate scientists are not presenting the full set of risks. They're presenting risks. I mean, talk to any individual climate scientist and they'll tell you how worried they are about things. But when it comes to IPCC and all these things, the risk assessments are done in certain ways so that they can be, first of all, done, right? Using information they have available. And very often when they don't have the information available, they leave it out. It doesn't mean it's not going to happen. It just means they just don't know how bad it could get. And then policymakers see 2% loss of GDP, and they realize there's no way we should cut back on fossil fuels. That'll hurt GDP far more than that. So let's keep going. And they're making an incorrect decision based on incorrect information.
I had that look on my face because Jeffrey posted in the chat a thread and I clicked on it and it's Ted Nordhaus. And then I'm like, I don't think that's quite right. I don't think that's the Nordhaus. And so I'm Googling and whatever. And it's like, yeah, no, it was. So Jeffrey, that's his dad. The guy who won the Nobel is William. Ted is his son. And he founded the Breakthrough Institute, which is in Oakland.
Oh. Yeah.
And yes, the Breakthrough Institute is they are, what did I read here? They are committed to the Breakthrough
we should
Institute
get somebody from the Breakthrough Institute on here. I debated Michael Schellenberg from the Breakthrough Institute at a Berkeley climate conference many years ago.
Schellenberg is in them? Is in there?
Used to be.
Oh.
The not denier. Yeah, these are not deniers. They're lukewarmers, I think they're called.
Yeah.
It says the Breakthrough Institute is a global research center that identifies and promotes technological solutions to environmental and human development challenges. And everything I can see on their site is like, I don't know, it seems like stuff we would subscribe
to. Yeah. The Breakthrough Institute looks very positive, but it's the kind of climate group that the fossil fuel industry would fund, and maybe they are, by the way.
I went and looked at the funders because I wanted to be sure, and I didn't see any obvious
No, you don't see
ones.
it.
Yeah.
But Schellenberger left, I think, because he got too hot to handle for them. I mean, he just got too obvious. He wrote, denier books, basically, and stuff.
Oh, he's the RFK of climate, I think, or something.
Yeah, he's very similar to Bjorn Lomborg, who tries to come off as, what was he? as an environmentalist, but he's the opposite, right? And
Yeah,
they
he
use cherry picking of data. He got very upset. He didn't know he was going to be, he didn't know who I was when I got on this panel with him. But I looked him up ahead of time and realized what his story was. And so I was ready. And he did not like that at all. He stormed off the stage at the end of the panel. But anyway, yeah, so that's Breakthrough Institute is a lukewarmer thing. They're very
interesting.
pro-nuclear. They're pro-nuclear, I
Mm-hmm.
believe.
Yep.
And they're anti-renewables. I don't even know how they justify that, but somehow they try to justify that. And but in reality, they're sort of, well, let's keep doing what we're doing with fossil fuels for a while longer while we get all these wonderful replacements in the future. Um,
I can't I don't I yeah, I do not know how you could possibly turn down renewables. That is just cuckoo. Um,
so Stephanie Brown asks, is there a global climate policy? Where can I read this, please? Well, you can look at
I just
the Paris
posted,
Accord. The Paris Accord. Yeah.
well, this report she'd asked for.
Oh, oh,
Um,
oh, is it the report? Okay, yeah,
well,
the report, by the way,
that
I
was her
should mention
question
the report
prior.
itself, if I didn't say it already, is in a link to it is in the show description on YouTube. So just go there and you can get a copy of the report.
And there were some questions. If science can barely translate into net zero initiatives, how will convincing intelligent people of SRM make it policy? Is that the carbon lobby and is that is it that the carbon lobby and politicians will come on board? Is it hopium?
Well, I'm sorry. So repeat the question. I just posted the link on Clubhouse, by the way, for anyone in Clubhouse. I just posted the link there. So say the question again, please.
If science can barely translate into net zero initiatives, how will convincing intelligent people of SRM make it policy? Is that the carbon lobby and politicians? Is it that the carbon lobby and politicians will come on board? Is it hopium, SRM?
No, I think SRM is a very different kind of thing in that it's relatively easy to do. I mean, nothing's easy to do, but it's billions of dollars a year instead of trillions of dollars a year.
Mm-hmm.
It basically means you build special airplanes that can fly higher than normal airplanes fly. Planes can already fly that high, but they're usually small, so you need to make big airplanes that can go that high. And then there's a lot more research to do about where you put it, but we know how to do it. It's not that hard. So from a technical engineering point of view, it can be done, and it can be done fairly soon. And we know a reasonable amount about it because, again, it happens naturally a few times a century when there's a very large volcano like 1991 Mount Pinatubo. There's models. They're doing lots of models. There's a really interesting paper out recently, and I want to get the author on. I've invited her on uh, about how using SRM can strengthen the AMOC if it's done correctly. So there's that kind of thing, preventing tipping points. So uh, there's a lot of concern about SRM. I think mostly people like you're screwing around with the climate, which yes, we are. There's no question about it. But then again, I say, well, maybe you should have thought of that 200 years ago when we started screwing around with the climate. And we're screwing around with the climate in a big way. And it's like, okay, you smoked 3 packs of cigarettes a day for your whole life, and now you're against chemotherapy because you don't like screwing around with your body. What's that all about?
Right. Your body's
So
now a temple. Right.
yeah, my
Yeah.
body is
Yeah,
not simple.
the screwing around with the climate train takes a long time to stop after you apply the brakes.
Yeah, yeah. Well, we're not even we got our foot on the gas right now, by the way. So there's not even,
Literally.
yeah, literally, actually, literally.
Um,
Uh, okay, so the link I
I
provided a link. Yeah.
You have the link in YouTube and in Clubhouse. I put it here in our chat. The
Oh, I see. The Nordhaus was getting confused between the two Nordhauses. Okay. And by the way, I don't think Nordhaus was an anti-climate guy. It was just an economist who said, assuming, I know there's a famous joke. Maybe I'll tell it. I'll tell this famous joke. I don't know if it's going to be, people find it relevant, but there's three people in the desert and they have three cans of beans. One's a physicist, one's an engineer, one's an economist, and they don't know how to open the beans. And so the engineer says, "I know how to open the bean. I'm going to throw it up in the air to 12.7 feet, and the force when it hits the rock below is going to be stronger than the tensile strength of the steel of the can, and it's going to open." So he does it, boom, it works, but all the beans end up in the sand. So the physicist says, "Wait, I know how to do it." So he says, "I'm going to take my glasses and focus the rays of the sun on the can. The internal pressure is going to build up, and I've done the calculation to show that this is going to be enough to open the can." So he does it, and indeed, boom, and it breaks open the can, but all the beans are on the sand, and so the economist says, "I know how to do it without getting the beans on the sand." And they go, "Yeah, how?" One, assume a can opener. So anyway, that's the joke. And there's a lot of assumptions going on in these report that their calculations are right if their assumptions are right. But it's not true that 87% of businesses aren't affected by climate change. And it is true that there will be much larger impacts and tipping points and things that they just left out. They say they left them out. So they're not lying. If you do, I don't know, if you did a model of the US economy, but all you did was include pizza restaurants and nothing else, I don't know, you'll get something. It'll be interesting. You could write a paper on it, but maybe, just maybe, it's not going to reflect the entire US economy. So
Yeah.
anyway,
I feel like I get very, I sound very flower child about it, but it's like that you can't keep doing things the way you've done them and then expect everything to be the same. And I think, and that's just, everybody is just sort of like, oh, it's yeah, the climate, it's really a problem. Oh my word, we've got to do something about it. And then they fly to wherever and they drive every day, and they still buy gas powered cars. And it's yeah, I don't know how we'll get people to, get off the fuel.
well, and let's get back to the report. And I'm not going to go through the details here. There's links now on YouTube. There's a link in Clubhouse, and there's a link on Zoom, so everybody can get a copy of the report and read it yourself. Just very high level of what they're saying we should do. We should have an actuarial approach. Do what insurance companies do when they look at risk. Do it the right way. You do risk identification, you do risk measurement, risk control, risk financing, and risk monitoring. That sounds very basic. And what they're trying to do here in this picture is we had a planet that was healthy. Now it's at risk, and there's two places it can go. It can go to a turbulent Anthropocene, insolvent, risk of ruin is the phrase they use. Or if we do the right things, we can have, well, by the way, speaking of the denial thing, if Kevin Anderson were on here, he might say this is BS. We're shooting for abundance and prosperity while at the same time, we're having our cake and eat it too. We have a wonderful green world, and we didn't have to cut back on anything. That he thinks that's BS. Let's put it that way. But still, it could be a hell of a lot better if we started taking these risks seriously and acting on them. What you do with risk management and risk, this is not just for climate. This is if you're looking at, fire insurance or anything else. Assess risks in relation to the objectives or interests. Identify the biggest risks. Consider the full range of probabilities. Use the best available information. Take a holistic view. Be explicit about value judgments. Recognize that value judgments are essentially subjective and present them transparently so they can be subject to public debate. And look at probabilities, impacts, and time horizons. And so now they have this thing called the resilience principles. So they take the word resilient and they spell it out. And for the following principles: risk-led, Earth system is primary, systemic risk assessment, imaginative scenarios, latest science, incentives to flag risk, educate stakeholders, nonlinear risks and tipping points, collaborative across disciplines, and effective governments and reporting. I think they started with resilience and filled in everything from there, but okay. And then notice that the economy is a wholly owned subsidiary of society, and society is a wholly owned subsidiary of the biosphere, rather than the other way around, which is the way we normally look at it. So, and this lays out more detail on what each one of those means. And rather than go into all of this, this is really get into the details of the report. This is one thing I didn't understand it last week when David Keith said that tipping points are man-made structures or ideas or something like that.
Constructs.
Constructs. So these are, they listing some of the tipping points. This is from a paper that came out, was it last year or 2 years ago? And we talk a lot about a bunch of these, right? AMOC shutdown, Amazon rainforest dieback, boreal forest, fires and pests are changing. Greenland ice sheet, ice loss is accelerating. Arctic sea ice is reducing, and that leaves dark water to absorb sunlight rather than ice that reflects sunlight. So that's going to make the world hotter as the sea ice disappears, and it's already happening. Permafrost is thawing. Permafrost holds twice as much CO2 as the entire atmosphere holds. So you don't have to lose a lot of the permafrost to CO2 and methane to make a big problem. I mean, a few percent would be enormous. Coral reefs are dying off. These are all things happening, by the way. It's not even like maybe will happen in the future. These are underway. Wilkes Basin East Antarctica ice loss is accelerating because people thought at first that East Antarctica will grow in ice as weather warms. But that one is also losing ice. And of course, the West Antarctic ice sheet is ice loss is accelerating. So those are things not in any of the models, by the way. Any one of those is mind-boggling. So there we go, talking about tipping points for growing wheat and corn. And some of these have black lines where you lose 100% of the ability to grow things. So, and output. Again, this is how to present the information to policymakers and a dashboard. And then they have appendix on impact matrix. So a great report, very timely based on our own programming here. When I was having this after our show, going back and forth with David, and that this report popped up exactly on the topic of GDP loss. So I thought that was very interesting. I do recommend you take a look at this report. It is written to be relatively understandable. If nothing else, you can just read the executive summary, which I read here. So I guess maybe you don't have to read it yourself, but send it to your friends, especially if you know anyone who's a policymaker, either from the local council member to a senator. Do you think Trump will read this report?
Oh, sure. He'll get right on it. This actually, the change, and to keep going as usual, it reminds me of what do we do in the aftermath of LA? So Governor Newsom is, ready to do a Marshall Plan to allow, rip off all the red tape so that families and people can rebuild. And they're going to rebuild it exactly the same way in exactly the same space. And it's like, that's bananas, And
they're going to build it using wood framed homes, by the way.
Yeah.
Where the U.S. is the only place not the only, but one of the few places that use wood frame homes. In Europe, it's stone and things like that. And those homes are around for hundreds of years. Ours are around for 50 years.
They're afraid of the masonry because of the earthquake risk.
Well, that's just in California, but everywhere they're using wood. And
sure,
you can use steel, by the way, steel frames. I have a friend who wanted, I don't know where he's at on it, wanted to rebuild Paradise, California with steel frame homes. It costs a little bit more up front, but you don't have termites. They last forever. They totally greater than an earthquake. They're stronger than wood. Um, and you can also have active fire suppression. There were a few homes that were saved. I know when I redid a house a long time ago, this is before people talking about climate change, but um, I did buy a fire pump, and somebody did save their home with a fire pump. A fire pump, it's just a water pump, and you throw one end in a pool, and then you have a fire hose, and then you add foam. And I'll tell you this one little story. This house it was an old house, and it had wood shingled roof, and the guy took the fire hose and he sprayed the water on the roof, and the water came off the roof just like you would expect if you spray water on a roof. And then he hooked up the foam, and only a little bit, it's soap essentially is what it is.
Hmm.
And a tiny bit goes into the water stream, but it breaks up the surface tension of the water. He sprayed the water on the roof, and no water came off the roof. It just absorbed into the roof because the surface tension wasn't there, so it wasn't rolling off. Anything it hit, it would just sink in. So it made it like 10 times the water 10 times more effective at fighting a fire than regular water. And this is
That's
stuff from 20 years ago, maybe
huh.
longer than that.
I
So,
and
and you can
I
get that. And you can also get similar systems for your house. That's essentially a sprinkler system, not inside your house, but on the top of your house. And when it senses hot embers flying onto your roof, turns on a water spray with that soap in there and everything, and protect your house. And there were the few homes that were saved in the not Paradise, was it
Palisades.
Palisades fire had those systems.
That's and that is I just last night watched. I'd love to pass on Daniel Swain with on a show Factually, and he was addressing some of the rumors and that have gone around about management and effectiveness of the firefighters. I mean, it makes so much sense. And it was so great to hear from him. He said that essentially this was a blizzard of embers, and that's what made things spread so far. And that yes, we had help from other areas that were coming in, but we're talking about the magnitude of because it was 80, 90, up to 100-mile-per-hour winds
Yeah.
that were blowing these embers.
Mm-hmm.
And helicopters are off the table. They would have had to have 50,000 firefighters to try even have a chance at these houses. And then he was addressing about the water and why the water, it seemed like they ran out. It wasn't that
They didn't run out. Yeah.
it wasn't that well, in some cases they
Well,
did.
the water pressure wasn't enough to reach up the hill, right? Yeah.
Well, he was saying that the reservoirs were indeed full. The problem was that, well, one, there is no municipal water system on Earth that is set up to be able to handle the water demands of all of those fire hoses trying to put out all of those fires. And he said,
Right.
even if you had pumper trucks and whatever, how many were you going to have? Because you have thousands of homes that were affected. And also the one that I was like, oh my gosh, yeah. When every one of those houses is burning down, as soon as the pipes are compromised, they're all leaking. So every one of those homes is then, using water in an ineffective manner. The home is gone. There is no way to repair it. But water is bleeding out that can't be used for the homes that could potentially be saved. It was just like the most, I'm sure a lot will be learned in firefighting from this. But the one thing I keep going back to is it hurts a lot to hear, oh, okay, we're just going to let them go rebuild. Like, I get that feeling. And I know that if it were my home, I would want it back just the way it was as quickly as possible. But
Mhm.
that is part of the problem. It is just going to happen again. We need to start thinking about how we have homes for
Well,
everyone,
I do
and
think
that they
that
aren't going
homes
to
in these
burn.
high-risk areas should have these first of all, battery backup, because one thing that happens, you lose your power in a fire, and therefore, if you have a pump to pump water, it's gone. So you have battery backup. You have a local water supply. You don't need a pool. You can just put these little cisterns, these little big, basically big plastic tubs in your backyard, fill it with water, and have a pump that can spray water on top of your house. And I mean, it's not super cheap. I mean, maybe $50,000, but that's, probably you'll save that on your insurance over 10 years, maybe, versus, what's going to happen now with insurance rates. So, um, yeah, so you made me think of, I don't know, anyway, I think we could finish up unless there are any questions or people want to raise
The,
their hand. Now
the
you can
only
raise your hand
the
from,
only ones I had from online that we didn't answer yet were um, about, well, one is that do you think that the UNFCCC will commission an IPCC SR 2.5 report? I have
well,
no idea. What do you
oh,
think?
these are these scenarios. I think isn't there there already is an SR 2.5 report, I thought, but I mean, or something that addresses it. It's
It's
mentioned
SR
in
15 is the report, the one that led to the Paris Agreement, that we shouldn't go over 1.5, and that's, since then there's only been the regular IPCC reports.
Okay. And then the other is about
well,
SRM, putting sulfur in the air. Doesn't that make more acid rain and then have less trees?
no, so acid rain comes from the sulfur we put in the troposphere where we live. And that is, and we put a lot of it in, and that's one reason we cleaned up our sulfur emissions. So we put sulfur scrubbers on coal plants in the United States, and that lowered the sulfur, and that also increased warming, by the way. And China is doing that now too. So that is going down. As David Keith mentioned, putting sulfur, cooling the Earth a degree using sulfur in the stratosphere versus sulfur in the troposphere is 1,000 times safer. It's 1,000 times safer because, roughly speaking, you need about 50 times less sulfur for the same amount of cooling in the stratosphere because it lasts a year instead of a week. And also, it's distributed over the earth and over the oceans as much as the land, whereas the sulfur from a coal plant just kills everybody nearby, whereas this one spreads it out, and the ocean's the world is, 2/3 water. So most of it is harmless. And then it comes down in rain rather than in breathable air. And so for all those reasons, it's much safer. But there's still a little bit, I mean, it's of acid rain, I guess, but it's, again, much less than what we're doing today. So another way of thinking about it is we can reduce our pollution by 95%, take the last 5%, put it in the stratosphere, and we'll have more cooling. So that's one way to put it. I'm going to tell one more story about water and water backups. So during the big California earthquake in 87, or was it 89? 87?
89.
89? Okay.
Well, it was
One was
here.
the fire and one was the earthquake. I don't remember which was first. Um, but I went to a Cornell professor who studied the effects of it. So it turned out that they had a big water system in San Francisco to fight fires, and they knew if in an earthquake, the pipes could break and they would lose the water. So they put shutoff valves all over the city and to stop that from happening. And they could shut off the right valves and stop the water from draining out. So the earthquake hit and broke the pipes, and it started draining out, and they threw the switch to turn on all the valves to shut off the water flow in the leaky pipes, and they were all powered by electricity, which was all shut off, and so none of the valves worked, and all the water ran out of the system, and that's why they had to use the fireboats to fight the fire. So
That
that's you gotta think these things through, folks.
Well,
he actually mentioned San Francisco's redundant system, but he was saying that it's set up to pull from the bay and the ocean.
Oh well, now, yeah. Well, they
Yeah.
also bought another fireboat. I just saw it the other day. Yeah.
Oh, we have at least four. I'm pretty sure.
Now
something similar happened, though it wasn't like the main story, but in the Palisades fire, DWP appropriately cut the power, during the highest gusts of winds to reduce chances of ignitions, and some but not all of the pumps that filled the cisterns to maintain the gravity pressure weren't working because of that. And that is also in addition to the fact that one reservoir was closed for regular maintenance. But that is the appropriate thing to do. It's just that you don't plan for these things, or we haven't been,
especially during the wet season.
Yeah, exactly.
Yeah, this is
Exactly.
supposed to be our rainy season.
I did see the
Exactly.
Eden fire had they had someone filmed the power line catching a tree on fire like the moment it happened. And so that they weren't doing as good a job cutting all those trees as we are up here in Northern California. I don't know, but anyway, we
Yeah, he
live in a
said-
risk. Let's summarize: we live in a risky world.
Mhm.
We are currently not assessing risk appropriately for climate change. The models that we've been using leave out many of the highest risks, and even though they're low probability, they're still very high risk. And you have to look at risk appropriately, the way an actuary or an insurance company would. This report from the University of Exeter Institute and Faculty of Actuaries is something worth reading, something that all climate scientists should read and all policymakers should read. It's a way of taking a look at risk seriously. We're not doing it today. And this is a step forward to have an official group like this present the fact that we're not doing risk assessment appropriately. It will hopefully begin to change the way we look at risk.
And I did want to read one paragraph that is the point that I've been hammering on for years.
Okay.
Current, and this is on let's see, page.
This is Eli speaking.
Yeah, page 31 of the report. Current approaches need expanding to deal with the high levels of risk and uncertainty. Scientists have been superb at equipping the world with detailed information on what is happening and what is likely to happen. This needs to be combined with risk expertise to assess consequences, tail events, and actions required to mitigate or avoid them. Given the high level of uncertainty, this is likely to require a blend of qualitative and quantitative scenarios combined with expert judgment. In other words, we've been focusing on the modal risks, the most likely risks for a long time, just because there's the least uncertainty associated with them. But that doesn't mean that the tail risks don't exist. We may have to face the tail risks, and we should prepare to face the tail risks. And we're not doing that because everybody is just like so demoralized about how lousy a job we're doing on the modal risks. But we got to face the tail risks.
Yep. Okay. Well, with that, I think we'll close it up. It's been an hour, 20 minutes, and guess not too bad for finding out an hour before the show that it won't be the show that we thought. We hope Tad is feeling better soon, and we'll have him back
Anyone
to
on
talk about
tap
the
for
Nile.
next week?
Oh yeah, Jonathan Foley, the head of Project Drawdown. So that will be a very interesting discussion next week with Jonathan. And again, we have a whole bunch of other things coming up. Jim Hansen, without knowing exactly when he wrote to me and said, very soon. It sounded like the paper should be out in a week or so. And this will be another one of those papers that are going to get everyone buzzing. And then we'll have him on shortly thereafter to talk about it. So that'll be fun. And then I'm lining up things with other people as well. And later, I think in March, Bill McKibben and others. But again, you're always welcome to suggest people. You can post it on Twitter or Bluesky to me, Dan Miller 999, or you could always write email climatechatclub@gmail.com. The club part is a leftover from the Clubhouse. climatechatclub@gmail.com. And thanks everybody for coming. Thanks, Stacy. Thanks, Eli. Thanks for everyone with the comments and the questions. And we'll see you next week with, please like, follow, subscribe, hit the notification bell, all that kind of stuff, because when it comes to climate, really is reaching other people that really matters. And you can help do that by getting the algorithm to send this to more people. And also you can follow us on Twitter, X, and Bluesky. Links are in the description. So see you next time. Thanks, everyone. Bye-bye.
Bye.